This is the heart of our energy management program, a Siemens Apergy building automation system. This system allows us to control 40-plus air handling units from one central location, including starting, stopping, changing of set points, opening and closing valves, trending, and changing of setting of other various parameters. We also control our entire cooling plant from this building automation system and monitor our electrical demand in real time via a gateway connected directly to our Siemens electrical switchgear. This gateway allows us to see our demand load in real time, which in turn allows us to manage that demand. We have found that the biggest impact in the operation of our three electrically driven centrifugal chillers. We're able to lower the chiller demand through monitoring of outside dew point, and chilled water temperature is adjusted accordingly. Higher dew point results in lower chilled water temps. Lower dew point results in higher chilled water temps, which saves energy. These temps can vary anywhere from 42 to 50 degrees. These field panels are all hardwired to various air handling units and other equipment devices such as pumps and HVAC controls, allowing them all to communicate back to the Apergy building automation system. This gear is interfaced through a gateway connection back to the Siemens building automation system as outlined previously. The dew point monitor, as mentioned previously, is the key controlling factor in setting the temperature in our chilled water loop. In the old days, chilled water was set at 42 degrees and left alone. We now allow the chilled water temp to warm up if the dew point is low, which in turn saves energy by taking load off the chillers while still at all times keeping our occupants comfortable. Variable frequency drives allow pumps rotations to ramp up and down dependent on demand, saving energy when demand is low. Vacuum pumps are used for suction in direct patient care areas. Vacuum is piped throughout the medical center. We had been using Nash water-style pumps for 30-plus years until a recent change to Becker air-cooled pumps. The Nash vacuum pumps have a water consumption of approximately 2.4 million to 3 million gallons per year depending on demand. They run 24/7, 365 days per year. The new Becker vacuum pumps that are now online are water-free and make vacuum by running motors at a higher speed using carbon sling blades to create vacuum. They do make more noise than the Nash pumps, but use no water. Both systems use about the same amount of electric. The Nash pumps are being kept as an emergency backup system only. This is an example of a large air handling unit which has variable frequency drives on the supply fan motor and also the return fan. This is an example of fluorescent lights that have been retrofit with new electronic ballasts and T8 lamps. We've also retrofit all of our incandescent style light fixtures with screw-in compact fluorescent lamps. Our three 1,200-ton train centrifugal chillers produce chilled water that is circulated throughout the entire campus to air handling units for cooling. The chilled water is comprised of a primary and secondary loops along with primary and secondary pumps that all pipe back to the head-end chillers. Heat is rejected via the cooling tower.